So this is on the first review on the second part. Now, let's look at the directions first. The directions say graph the data, so let's do that. You may notice that our x-axis only goes to 5 and I need to go to 10. So I'm going to change it to go by 2s. And you may notice our y-axis only goes to 5 and it needs to go to 500. So I'm going to change those to the hundreds. Everybody go with that? Because the test generator only gives you this one table. You might have to, or your one graph, you might need to change your units. So it's just saying graph it. So hours and miles, I've got a dependent and independent variable there. A 150 is right here. A 4220 is about right here. After 6 hours, 300 miles, that's about right there. 7 hours, 320, that's about right there. 10 hours, 500, that's about right there. Now, is this a continuous or discrete situation?
Discrete.
He's teleporting time to time?
No, continuous.
He's driving a car, so that means he's going every distance in between these, unless he's back to the future in it or something. Okay? So there's the graph. So that's first part that it wants. The next part it asks for is show the rates of change. So why is it asking for multiple rates of change? Lauren.
Because it's not, there's no slope.
Yeah, it's not linear, right? So there's different rates of change depending on intervals. So this is not a requirement, but I would suggest getting organized. So I have an interval from 1 to 4 hours, from 4 to 6 hours, from 6 to 7 hours, and from 7 to 10 hours. So there's different rates of change at each one of these intervals. And if we've got miles and hours, we want our answer to be what per what? Miles per hour, which also works if you do the difference in y values over the difference in x values, just like the slope. So from 1 to 4, they went 170 miles in 3 hours, which would give us 56 2/3 miles per hour. Is that right? So that's the rate of change from the interval from 1 hour to 4 hours. What about 0 to 1? That's not on there. What about 0 hours to 1 hour? What's the rate of change? 50 miles per hour. Okay, so let's look at 4 to 6. It goes up 80 miles over 2 hours, so that's 40 miles per hour. From 6 to 7, it went up 20 miles in 1 hour. So that's 20 miles per hour. Slow down a little bit there. I think I would go nuts going 20 miles per hour for an hour. Okay. And then 7 to 10. What is that? 180 over 3 hours? For 60. And then you might have to do something like, you might have to interpret that too. Once if I asked you like, what was his fastest time? What's his fastest interval? Like 7 to 10 hours? He was going, like you could have to interpret this too. Also, if this is the highest rate of change, what should be true about that section of our graph? Should be the steepest one to it, is it?
Yeah.
So there's a good check. There's a good check there as well. So are you seeing like that question's not like crazy brutally difficult or anything? It's going to be difficult if you try to memorize how to do it. It's going to be fine as long as you just say, what is it asking? What information do I know? How do I use that, right? Technically for this, right, I can only get it in this equation, right? This is the y-intercept. And if I'm going to get it in standard form, I'm going to subtract -1/2 x. Now, technically for standard form, this leading coefficient needs to be a positive whole number. So I would multiply everything by -2. And I'd get x minus 2y equals 2. And why this is nice is I can look at this and say the x-intercept is 2 and the y-intercept is -1, which means the strength of standard form gets to be the strength.
So is what I got wrong?
I probably wouldn't mark it wrong, but this is like
What?
the bomb. Okay. It's technically not standard form unless it looks like this, but I guess you can multiply both sides by -2, y is -1. It's not that hard to get the intercept still. Just when you get that leading coefficient to be a positive whole number, it's like real easy. Yeah. So number 63 on packet. Number 2, it gives me this point, and it needs to be parallel to this line. So if it's parallel to the line, Spencer, what does that mean?
It's going to have the same slope.
It's got the same slope. So I'm rocking a slope of 2 through that point. What's my only vessel? Well, not my only, but what's the best vessel to get a point and a slope into an equation? Okay, so y minus y1 equals mx minus x1. You good with that? Now the directions say get that in slope intercept. So the goal is y equals mx plus b here, right? So I'm going to distribute, and I'm going to isolate y. I'm going to put Spencer in the closet. Feel me, Spencer? There's your answer. Now you can always check it, because this point should work in here. Remember, xy is just any point on the line. That's a point on the line. So if I plug in -5 for y and -3 there, I get -6 plus 1 is -5. That point makes my equation true. Guys, you can check everything because the ordered pair needs to work in your equations. Because that's all the xy is in your equation, an ordered pair on your line. Which ordered pair on the line works for x and y? All of them. Yeah, kind of a trick question. Cool. Next question. Perpetrator is perpendicular. So I need it to be perpendicular to y equals -7x. So Spencer, what do you know about slope if it's perpendicular to that?
It's opposite.
Flop is it. Found it on Urban Dictionary even, okay? So I need that slope and that point. I got a point and a slope, point slope form. Y minus y1 equals mx minus x1. And we're to distribute. Now we subtract 4 from both sides. Hey there, Spencer. I know I cruised through the algebra, but I feel like you should be able to solve for y. Yeah, what?
On the first packet, question 6 on the linear function practice. It's not like
Oh, yeah. So that's one. That is one that trips kids up sometimes, and it's a way easier problem than it looks like. So you gotta slow down and say, like, what is it asking? How do I get that thing? Not like there's not another problem like it. So there's a linear function. It has the same y-intercept as this. So let's work on that. What do you know about the y-intercept?
it's when x equals
So when x is 0, are you good with 2y equaling 8?
yeah,
Which means that y has to equal
4.
4. Which means my y-intercept is the point 0, 4. That's one thing they asked for, right? You good there?
Yeah, I just didn't know how to find the slope.
Now they want the slope. What do you need to find slope?
2 points.
You need 2 points. How many points we have? No. We got a y-intercept and that point. So y2 minus y1 over x2 minus x1 gives me a slope of 2/5. You got a second point when you got your y-intercept, right? Okay, cool. You go with that? Do you see how if you try to memorize what to do, that's tricky because you haven't done anything like that. But if you take a step back and say, what do I need to find slope? I need 2 points. Oh, I have 2 points. Do you see how the difference in thinking through it?
Yeah.
Yeah, don't memorize what to do. Yeah. So when you write the equation, it's going to depend on what information you get. And here's what we know. We know we got nickels, and we got dimes, and we've got a total. So usually when you get a total, sometimes when you get a total, what I'm looking at here is how many nickels plus how many dimes gives me the total of 780. You guys see it's just the Mr. Beast problem I gave you? But it's nickels and dimes for a total versus shoes and scooters. So here's where I'm starting. Here's my equation that's given. Now they're telling us next we have 66 nickels. So do we know x or y then? So if we know x is 66, I can take my equation, substitute in 66, and then what's my only variable left that I can solve for? Y. So 5 times 66 is what? 5 times 60 is 300 plus 330. So $3.30. And then it's just straight up 2 steps of algebra here. So I got 45 dimes. Cool? Yeah.
My question was like, so it said write a linear equation to find the numbers of dimes you have. So
Yeah.
I put in 66 when it like.
So that's kind of the solution. This is more the situation, right?
So when I write you.
So if you have a linear equation, you need x and y to be in it. Otherwise, it's not linear. Okay? Yeah.
Okay, do number 29.
29. Ooh, we're talking about rent? Some real world stuff right here. Okay, so let's check. So let's go over what information do we know? What is this right here? 800 square feet is 975. What is that in terms of the line? That's a point, so I'm going to write down my point. And then we got to watch announcements. What other information do I have?
Oh, we have another,
I have another point. And so if I have 2 points, what can I find? Slope. So the slope ends up being 1/2. I just remember that from before. So if you know a point and a slope, the way we get that into a linear equation is y minus y1 equals m, x minus x1. Okay? And then without doing all the computation, because we have to listen to the announcements, they're asking for 1,500 square foot office. And in our points, x is the square footage. So if you substitute in 1,500 for x, that'll tell you y, the cost. Do you see that?
yeah.
1,500 just goes right in for x because that's what x is. How many square feet in your equation? So some people will get that in slope-intercept form first and then substitute. You could substitute right from here. All right?